Alright, welcome back for Explain 2, where we're going to be modeling using quadratic function. Just in case you forgot what a quadratic looks like. It looks kind of like a U shape or parabola. And it could open upwards like a happy face, or it can open downwards, sad face. That's just a way I kind of remember what quadratics look like. You can keep that in your memory tool, or you can write that down on your notes. But the first thing we're going to do is they give us kind of the data that they gave us to before in Explain 1. They're asking us to find which animal population kind of forms a parabola. So take some time, make a determination of what you think that would be. We have the whooping cranes, the manatees, the bald eagles, which we found was linear, so don't choose that one. And then, of course, the terns. Yes, the least terns. Okay. And you should have chosen this one, which is our manatee population, because you'll notice it kind of goes up and then kind of like a parabola. Why is your choice the best fit? Well, this one, it kind of goes up and then down again. I know some students would have chosen the crane population because they're like, oh, it curves, but notice how it doesn't come back up. So here it starts a little high and then it kind of dips and then comes back up again. So let's use these data points. So here it says enter the data for your choice into your graphing calculator in the two lists and perform a quadratic. I have 0, 33, or 3,300. For 2, I have 3127. For number 4, and I'm going to take some time right now off screen to go ahead and record all these, but this is just good practice so that you can kind of find that there are data points that we could pull to make our quadratic function lists. So since we're using quadratic function, we're going to go ahead and use Desmos quadratic regression. Oh, thank you, Google. And I'm going to click on the first one I see here, and I will type in these values. So they give me a pre-populated value set. I don't really need those. I'm going to type in my own. So I'm going to put in 0, 3, 3, 0, 0. 2 and the partner for 2. So take some time. I'm going to go ahead and continue putting these in off screen, but take some time to put these in and make sure they're correct, because I almost made a mistake on, I think, the first one, because I'm trying to type and talk at the same time. So take some time to go ahead and type those in for all of our data points for the ones selected, which are these here. So I finished typing in all those. I'm just going to delete the ones that were pre-populated in the beginning. Ooh, that's nice that it just kind of deleted those for me. Alright, so it looks like here we have our formula, y equals a to the x squared plus bx plus c. So let's see what values we got here. So here we got about our a, b, and c values, so we can go ahead and actually write these down and then plot them into our piece of paper. So let's go ahead and plot in our a value, b value, and c value from the previous screen. That was about 51.7 minus 380 plus about 3,493. So let's fill in the sentence starter. It says where x, so here's our linear regression model, where x is the number of years after 2001, and I'm just going to look back to see if that's true. Yes, number of years since 2001. And the y value is going to be the Florida manatee population. The number of manatees. I think they made a Geico commercial about that. I'm not sure, but you can look up what a manatee is if you'd like. Moving on to step 3. Now it's saying to graph the model along the scatter plot using your calculator, which we already kind of did using Desmos. So here we're just going to record what we got on the previous page as our equation. And we're going to just take a second look and see how close it really was. So I'm going to go ahead and minimize these and just see how close that data set was. So as I can see here, I have no graph. So I'm going to zoom out by a lot. Oh, there it is. I'm also going to kind of take my two fingers, because I have a touch screen, and kind of put them on my x-axis and kind of just stretch this out a little bit. But I have a graph. It shows the points that I have as well as my data. Now, although it's not perfect, in fact, there's a couple that it actually misses. It's kind of, no, it's not really. It's actually not that close at all. But you know, it's a lot better of a model than, let's say, a linear function or even an exponential function that we'll be going over in the next explain. So I would write in here, looking at my model, this model actually would be is kind of off, or maybe just not close to the data. Again, you can use whatever adjectives you'd like, but as we can see here, it's not close at all. So in part B, they're asking us again to find a quadratic function. This time we're using, some of the automobile data. So take some time right now and try and figure out which of these data sets would be most close to a quadratic function. Remember, a quadratic function can be a parabola opening upward or downward. So take some time to work that out and see what you would decide. And it looks like possibly the miles per gallon might be the best data for a parabola. Obviously not this one, because we found this one to be linear, and explain one. But let's try this out. It might be off like we did for part A, but let's go ahead and try this out. Choose a data set that appears. Yes, we have chosen average miles per gallon. So moving on, let's go ahead and enter the data for your choice in a graphing calculator in ToolList and perform a quadratic regression. So this one's nice in the sense that they did give us our points, so I'm going to go ahead and make this bigger and open up Desmos again so that we can type in these new values. So on here I'm going to type in 0, 23.1, 2, 23, 2, 4, and the partner for that one would be 22.5. So instead of using the years 1996, I'm writing 0, because that's the graph that's shown. 1998, I'm writing 2, because that's 2 years after 1996. 2000 would be 4 years after. 2002 would be 6, and it kind of looks like it follows that pattern. 8, 10, 12, and so on and so forth. So take some time. I'm going to do this off screen to kind of type in these values and make sure they're correct, so that way we have the best model possible. So it looks like here that our points actually are a lot closer than in part A, because as you can see in the last one it was pretty off, but here it's pretty spot on. It's a lot better than the last one. But here is our A, B, and C values. So let's go ahead and record these onto our piece of paper here. Back to this, we'll go ahead and type in our A, B, and C value, which we found to be 0.039, negative 0.392, and positive 23.39, where X is the number of years after or since 1996. And Y is the miles per gallon. And if you're wondering that's what this means. Miles per gallon is always really important. You want something that has good mileage, so that way you can get more miles to drive per gallon, because gas is a... Alright, part C, we're going to just record this right here, 0.039, and that's why it's important to write it down on a separate piece of paper. like, so that we can write this down. And then it says the model is, do you think it's close? Not close? Very close? I'll let you kind of write in your own adjective. And just to remind you what that looked like, let's go ahead and look at this here. As you can see here, is actually pretty close. So I would write here, you know, pretty close. But once you finish doing that, let's go ahead and go and do the problem in your packet, which is number 7. Try it out, and we'll see you in for the next video.